Welcome back to the YOLO custom detection series part 3. In this tutorial we will do training on a YOLO dataset. Let's start the work. Okay, in the last tutorial we collected the images and we created the txt file. In the txt file there is a number of parameter like the class and the xy, mean x and mean y of an object that represent its position in a image. Okay, then we have to change the class label. Okay, it's okay. The first thing, this 0 represent the class. This is class 1 and it's okay, but in the next images or next class we are detecting monkey. To recognize so for this we have to change its class label. Okay, then it will make it to 0 to 1 because I use 0 for chimpanzee and 1 for monkey. Save it and make changes to all txt file corresponding to a particular class. Okay. Until this I am pausing the video. Okay, I just made changes to all txt file and made the first parameter 1 because 1 representing the class label that I use for monkey. So I use 1 for monkey and 0 for chimpanzee. That is the thing that we have changed from the previous example. Okay, if you have a more than 2 classes you can train like that we did in a last tutorial and make them to 0, 1, 2, 3 according to your number of classes. 0 represent to the first class and n-1 for a last class. Okay, so copy the txt all files along with the images and open the darknet folder that we installed in the first tutorial. Go to build darknet 64 data and in object folder paste here. Again copy another images. Again go to the build directory 64 object and paste it here. So everything is done. Now we have a data and its label. Okay, so for this you have to copy. Okay, this is the method to train and to how to detect a custom object. You have to create YOLO object config file with the same content. Copy this file to this. So YOLO walk.config. Okay, YOLO walk.config. Where it is? It must be in this folder. This is the file YOLO walk.config. Okay, I copied it. I go outside the config folder and paste it. Replace. Okay, and copied it and I already renamed it with the YOLO Vogue config like this. No, YOLO Vogue dot config to YOLO object dot config. Sorry. This is the file YOLO Vogue dot config. Copy it and paste. YOLO Vogue dot config, rename it YOLO object dot config. Okay, the name YOLO is, sorry, here is already a file. I renamed it in the last, I don't know where but I renamed it. So this is the file YOLO object dot config. Then for example okay, change line class 20 to the number of object. So I have two classes, so we need filters equal to 5 plus 2 7 into 5 35 and classes 2. Okay, made changes to this file, open it, gedit, and go to the 224. So here is a filter, we need 35 and here is classes, that is 2. Okay, and I am working on a CPU, so I made subdivision to 1, batch equal to 1. If save it. It's done. Now we have to create YOLO object. Okay, it's done. Now we have to create object dot names in the data folder and object dot data in a data folder. So copy it like this, and its directory will be the data within object dot names. So go to the data, create a new file like object dot data, go there and paste it. Here is two classes, train test txt, save it and create a new file like this, object dot names. Okay, every new line corresponding to a new object. So for class 0 I use chimpanzee, and for class 1, for class 2 I use monkey. Okay, I saved it. If you have only one object that you want to detect, then only enter one name here and make the number of classes is equal to 1. Okay, saved it. Then it's done. We have created a YOLO object.config, object.names, object.data, and we put the all data images in the object folder. So, and we also converted the classes. Okay. Now we have to create a train entity x64 folder. Right click and open it. So here is the current directory. This is 64 like this, and in your current directory there must find your path data like this: data, object, and the percentage text. It must be around 30, and file training and file test. So it will create a train and testing file, and here we make the test or train folder or file for detection purpose. Okay, save it. And open the terminal. Write python process.py. What happened? Did they mail the train file? Oh no. Okay, there is a problem. Okay, welcome back. There was a problem in my directory, so I resolved it and made the changes to process.py file, and just open the terminal and type python process.py. okay, everything is done. Now we get the train.txt file. Here we got the images that will be used for training purpose, and we got the test file that will be used for testing purpose. Okay, here we done, and now we have to download the pre-trained weight, and just downloaded it, and I already downloaded it. Okay, I downloaded the file. This is pre-trained weight 76 MB, and I put it in a x64 folder. Now copy this command, this one, and open the terminal, paste it. Okay, so here we are. So it's for window, darknet, and we are in Ubuntu. Put this one. This is the execution file, detector keyword for detecting, train for training, that we created the training file. It will be using here. Data slash object.data. This is the data file, and this is a yolo object.config and darknet.config file. Okay, run it. So you can see there it started the convolution. So our training is started now. Here we have 29 convolution network along with the conmax input filter size, 32 filters, 64 filters. There is padding of 3x3, sliding input images 416x16, and output like this. So here's the learning rate is 0.001, momentum is 0.9, Our training is started, and initially we got loss of 10, and it took 120 seconds to load, to process it, and in the 9 iteration we got the loss 5. Okay, it's good. My CPU is getting hot. Okay, where do we have to stop our iteration? After each 1000 iteration you can stop, later start training from this point. Okay, after every 100 iteration or 1000 iterations, or multiple of 100 iteration or multiple of 1000 iteration, the training weights are saved to the backup folder, so you can retrieve data from the backup folder. Okay, here what we got. Okay, where we have to stop our training, it is given in the validation set, training set, I think. Okay, here we get, after getting a loss of 0.06 average, it's enough, and it will provide the better result. The person get that loss, average loss, after 9002 iterations. It's very much, and we are only at the number 10 iteration, and our loss is a 4.63 average. Okay, run it and leave the laptop. I'm leaving this laptop until I got the iteration around 1000 or 1200. That will provide me a pretty good result. Okay, thank you for watching it. After the every 100 to 100 iteration or multiple of 1000 iteration, the data will be saved here in the backup folder, like this: YOLO object 200, 300, 400, like this. Okay, here we done, and we will see in the next tutorial, part 4. There we will detect the images, the custom images. Until, try it. Thank you for watching me and my series. Like it, subscribe it for an